Welcome. Today we're going to walk through how to protect controlled and classified information, or CUI, inside manufacturing and OT environments. My name is John Paz, and I work in governance, risk, and compliance. Let's break this down in a way that's practical, clear, and easy to follow. Here's what we're covering today. First, we'll define what CUI actually is. Then we'll look at where it shows up in manufacturing environments, especially in CAD, CAM, and CNC workflows. We'll talk about OT systems, CMMC requirements, diagrams that show how everything connects, and finally some recommendations you can take back to your organization. CUI is information the government owns or controls that must be protected under law or policy, but isn't classified. In our world, it almost always arrives as a technical data package. The critical concept is derived CUI. If you generate something from CUI like a toolpath or G-code from a protected CAD model, that output is also CUI. The driver behind all of this is DFARS 7012. And CMMC is how the DoD verifies you're actually protecting it. Think of CUI as moving through three stages. In engineering, the TDP and CAD models come in and the CAD CAM workstation turns them into toolpaths. In programming, these toolpaths become G-code derived CUI, which loads onto the CNC machine. So now the shop floor is in scope for CMMC. Finally, the machine produces logs and sensor data that may also contain CUI, and all of it should be landed back in a secure enclave. The takeaway: protection has to follow the data the whole way. The diagram shows the full life cycle of CUI. It starts with the technical data package, moves through the CAD and CAM, becomes G-code, runs on a CMC machine, and then generates logs that may also contain CUI. Every step in this chain needs protection, not just the engineering workstation. OT is the operational technology, the machines and controllers that run the physical process. It behaves very differently from IT. Long life cycles, legacy operating systems, often impossible to patch or put an agent on, and availability comes first. That's exactly why it gets missed in scoping. A CNC machine is in scope the moment it runs G-code derived from CUI, stores it, or transmits it, even an air-gapped one. The single test is whether the asset processes, stores, or transmits CUI. Let's open up the machine. A CNC isn't one black box, it's several components, and the G-code program is derived CUI that touches almost all of them. The HMI displays it, the controller executes it, the memory stores it, the network or DNC link receives it, and the USB port can sideload it. The only part that never touches CUI is the physical motion, the spindle and axis. That's the visual reason the machine is in scope. Protecting the building it sits in isn't enough when the data lives inside the controller, the memory, and the ports. Now the data paths. CUI originates at the programming station inside the enclave. It reaches the machine one of two ways: over the network through a DNC link or file share, or physically on USB or removable media. Once inside the dashed gold boundary, the controller executes it. The memory holds it and the machine cuts the part. On the way out, logs and probe data that may contain CUI should flow back to the secure storage. The reason this matters: there are only a handful of entry and exit points. So if you broker and encrypt network transfers, lock down USB, authenticate operators, and protect the logs, you've covered the machine's real attack surface. Not all assets are equal. CAD workstations are obviously in scope. Programming stations are in scope. CNC machines are in scope when they run G-code derived from CUI. Even air-gapped machines can be in scope. The key is whether the asset processes, stores, or transmits CUI directly or indirectly. If you handle CUI, you are looking at CMMC Level 2, which maps to NIST SP 800-171. The 110 controls scored across 320 objectives, verified by an independent C3PAO. The important nuance for manufacturers is how specialized assets like OT are handled. You may not be able to put an agent on a CNC machine, but you still must document it in the SSP, show it on your diagrams, and manage it through the security plan with compensating controls. The families that hit OT hardest are access control, configuration management, system and communications protection, and audit. Segmentation is the highest leverage architectural move. On the left is enterprise IT, email, ERP, general users, which should have no direct path to CUI. In the middle is a controlled boundary, a firewall and brokered logged data flow with default deny between zones. On the right is the CUI and OT enclave, where the CAD and programming stations, the CNC machines, and secure storage live. The smaller you make that enclave, the fewer controls you have to implement and prove. Access control is where most OT incidents begin, so it gets its own slide. 4 moves. Enforce least privilege and role-based access so operators get only what they need. Require strong authentication, MFA into the enclave, and no shared or default accounts. Lock down remote and vendor access by brokering time boxing and recording every session. And don't forget physical access. The shop floor, the controllers, the USB ports, and the maintenance laptops are all attack paths. This ties the controls back to the life cycle we saw earlier. At the source, encrypt and control access to the designs. At the workstation, harden the endpoint and require MFA. At G-code generation, mark and handle the output as CUI. At the machine, use segmented and compensating controls because you can't always patch it. In the logs, remember, CUI can hide in telemetry, so classify and restrict it. And in storage, encrypt the enclave and protect the backups. Layered controls matched to where the data lives beat a single perimeter. CMMC runs on evidence. The system security plan is the master document. Boundary, assets, and how every control is met, including the OT you can't patch. Network and data flow diagrams show the enclave and segmentation. The asset inventory tracks every classified asset. The POA&M holds open gaps with owners and dates. Policies and training records prove people know the rules, and the evidence library should be gathered continuously, not reconstructed the week before the assessment. Here's the bottom line. OT is a critical part of CMMC compliance. CNC machines often handle derived CUI, and protecting that data is essential. With segmentation, documentation, training, and the right controls, you can secure your manufacturing environment and meet CMMC requirements. Thanks for joining me. Thank you for your time. I'm John Pazza, GRC consultant focused on CMMC, NIST 800-171, and securing OT in manufacturing. I'm glad to help with scoping, a readiness review, or any questions on protecting CUI across your CAD, CAM, and CNC workflows. Let's talk about next steps.